Hello, I'm Phil, and I will be explaining part 1 of lab 2. Here, I have wired the circuit in accordance with part 1, and I've also wired this to be D and this to be clock, button 1 and 3. So, following, we have also wired S and R to VCC instead of 0 because for this IC, S and R are both active low. So to confirm this timing diagram, first we have D as 1. As you can see, the bulb does not light up. Once you have clock as 1, the bulb lights up. And then we have when the D is 0 and the clock is clock, the LED will turn off as predicted. Now, once the clock is 1 again, once the input is 1 again and the clock is 1, the LED lights up. This proves that our timing diagram is correct. 3. Okay, so now I will explain the part for part 1 and the temper switch. For the temper switch, I'm assuming that the photo interrupter circuit will give a value of 1, which is high, once the circuit has been triggered. So I will wire the photo interrupter to clock, and I will wire D to VCC, which is high input, yes. So once the photo interrupter has been triggered, it will cause Q to go to high, and this state will remain, letting us know that the photo interrupter has in fact been disturbed. Okay, hi, I'm Phil, and I'm going to explain part 2 of our lab 2. Okay, as you can see here, we predict our frequency of our waveform to be 250 kHz when a 500 kHz input is given. Once we have wired with the D-type flip-flop, we obtain the expected result, which is the input is a 500 kHz frequency, but the output will be a 250 kHz frequency, which is exactly half of the input.
I'm Sam, and I'm going to explain part 3. So here, we are going to design a circuit with IC74HC161. We're going to count 1 to 6. So here we have 1, 2, 3, 4, 5 of output 1 and 6 with output 0. Because we are going to, with the output 0, it is going to activate the PE, and since the PE has an active low, so it will give an output of 1. So here, this is the design of the circuit. So we connect MR to VCC, CP connected to clock, and D0 is connected to VCC, D1, D2, D3 is connected to the ground, CEP is interconnected with CET and is connected to the switch module, and ground is connected to ground, and Q0, Q1, Q2, Q3 is our input, and the PE is the result of the output, and TC is not connected. VCC is connected to the VCC, and this circuit we have 3 NAND gates. So I'm going to show an example of how to run this circuit. So we are going to count from 1 to 6. Here we have 1, 2, 3, 4, 5, 6, and you will reset back to 1.
Hi, I'm Justin, and I'm doing part 4. Okay, basically to get 1, we need A. To get 2, we need D. To get 3, we need A and D. To get 4, we need C and D. To get 5, we need A, C and D. To get 6, we need B, C and D. Okay, so basically we'll have this circuit. It requires 2 NAND gate and 2 NOR gate in order to get the result. So A is connected to QO, and B is the product of Q1 and Q2, and D is the sum of Q1 and Q2, and the C is Q2. So as you can see, when I press this switch, it changes from 1 to 2 to 3 to 4 to 5 and to 6. Okay, for part 5 is actually the combinations of part 3 and part 4. As you can see, when I turn on the switch, it is 1, 2, 3, 4, 5, and 6.